Okay, folks, today's lesson is graphing linear inequalities. And guys, you know how to graph a linear equation. You just find the y-intercept, you put a point on there, and then you use the slope to find another point. You go up or down and then over, put that other point, and you draw a line through it. Okay? Now today what we're going to do is we're going to learn how to graph linear inequalities. And it's really pretty simple. I mean, it's taking what you know about graphing linear equations, and then there's a little bit of shading in here. So we're going to do some coloring today. All right? So let's look at this first inequality, and it says that y is less than 1/2 x plus 2. Okay? Now, if this were an equation, then what I would do is I would go up 2 on the y-axis, and I'd put a dot on the y-intercept at 2, because I know that's where the line crosses the y-axis. Now, we're going to treat this like a line because it's going to form a boundary for us, and that boundary is going to tell us which side solves the inequality. It's going to divide between the side that solves the inequality and the side that doesn't. Okay? Now, once I get up to 2, I'm going to go up 1 and over 2, and I'm going to put another dot. Okay? Now this is a pretty critical spot. I need to stop for a moment and let's talk about inequalities. There are 4 inequalities. There's this one, there's this one, and this one. Okay? This first one, this is called less than or equal to. Okay? And the next one is greater than or equal to. The third one is less than, and then the fourth one is greater than. Now this one says it's less than 1 over 2x plus 2. Now what that means is that it can't equal the line. This boundary line we're going to draw as a dotted line. And we know that all of the solutions are going to be less than that line. It can't actually be a point on the line because it doesn't say equal to. Now we'll see some later where, and I'm going to put this up and then take it out in just a second, where if this said equal to, then that means it can be the line, that there are points on the line that would solve this inequality as well. But it doesn't say that, so we're going to make the line dotted, and that dotted line tells us that none of the points on the line satisfy the inequality, but since this says y is less than, we're going to shade below the line, and all the points that are in this shaded area, any of them that we pick, when we plug in their x or their y, is going to satisfy that inequality. Okay? So this green point right here, I'm going to call this one -1, -1. If I plug that in, it would make a true statement. I'm going to put this point out here, and this is going to be -1, 4. That's not in the shaded area, so it wouldn't solve the inequality. Now, we don't have a lot of time to look at each one of these, but I'm gonna take the point that's in the shaded area and I'm gonna plug it in. So y is less than 1/2 times -1 plus 2. And I'm sorry, I should have at the beginning, since the y is -1, I need to put -1 over here. So you'll see I plugged in the y and the x from that first point. Now when I solve this, I'm going to get -1 is less than -1/2 plus 2. -1 is less than 1.5. And that's true. That's a true statement. And because it's in that shaded area, that's why it's true. Okay? The other one, and I'm going to do it very quickly, 4 is less than 1/2 times -1 plus 2. 4 is less than -1/2 plus 2. 4 is less than 1.5. That's not true. This isn't true. And of course it's not true because this point, -1, 4, is not in the shaded area. Alright guys, good job. Let's look at the first example.